Hey guys, welcome to my lesson on fractions, addition and subtraction. Hopefully you've already watched the previous video on equivalent fractions and simplifying. That is exceptionally important to watch before you watch this one on adding and subtracting. Now what we're dealing with today is questions like this. 1/3 plus 1/3, which is a fairly straightforward question which we'll look at. We'll get a little bit more challenging like 1/3 plus 1/6, and then ultimately a question like this, 1/3 plus 1/4. Okay, so what is the biggest issue when adding or subtracting fractions? Well, number one, in order to add or subtract these, we must be able to compare my two fractions. Now, we looked at that last lesson about comparing fractions. For example, what does 1/3 mean? Well, if I split up a shape up into thirds, 1/3 would mean that one equal part has been shaded. So if I'm looking for 1/3 plus 1/3, well, couldn't I just shade another third and then say, well, how many thirds do I have altogether? Well, in this case, we've got 2/3. That's nice and easy because we can compare the two fractions. Now notice though that 1/3 plus 1/3 does not equal 2/6. Okay, I have a saying in my classroom, if you've ever been taught by me, that if you add the bottom parts of a fraction, please imagine Mr. Pay throwing a book at your head, because that's what I would like you to believe. That if you do add the bottoms of fractions, that is what I would do. Probably not. However, at least it gives you an idea to think about something in your head. Don't add the bottom parts of a fraction. Just quickly too, can you remember what the bottom part of a fraction is called? It is called the denominator, as opposed from the top part of a fraction, which is called the numerator. So when adding or subtracting fractions, we can only add them if the denominator is the same. In this case, 1/3 plus 1/3, they are the same. So I simply add the top parts. 1 plus 1 is 2. That gets me the 2/3. That's because we can compare them, because the bottoms are the same. So what happens when we get a question such as 1/3 plus 1/6? Now, obviously 1/3 and 1/6, they're going to be quite different, because we know that, well, hopefully, that 1/3 is not the same size as 1/6. You know, if we look at a shape, for example, 1/3 here, 1/3 would be broken up into this amount here. What would 1/6 look like? Well, I guess if I did another box here and I break this up into 6, 1/6 would look like this. So if I simply said 2/6, that wouldn't really work because they're different sizes. So what can we do? Well, I could draw a line straight through here and make them both into 6. So now what you might recognize is what we've got on the right hand side or left hand side. We've got 2/6 and we're adding 1/6, which creates 3/6 altogether, which is the same as 1/2. So what we've done is actually what we did last lesson. We have changed or converted the 1/3 into, that word again, an equivalent fraction. Now, we did that by timesing the bottom and the top by the same number. For example, I can times 3 by 2, that makes 6, but what do I do to the bottom? We must do the top. So 1 times 2 is going to be 2. So what that actually creates is this 2/6 plus 1/6. The bottoms are now the same, so I can add the tops to make 3/6, or which is equal to 1/2. Okay, so equivalent fractions has a huge part to play when adding or subtracting. Often I do say adding and subtracting is actually the hardest things to do on pen and paper with fractions, most of the part anyway. Okay, let's look at 1/3 and 1/4. So they're both quite different. In question 2, we only had to change the 1/3. Okay, that's the only one because that was nice and easy. That changed into 6. But I can't change a third into quarters. So what we need to do is, what we come up with is a name called, we need to find a common denominator. Now that's what we actually did in question 2. Without realizing, we got a common denominator. In question 1, we already had a common denominator. So can you think of a number that both 3 and 4 go into? Well, hopefully you thought of the number 12, because they both go into 12, don't they? So what can we times 3 by to make 12? Well, we can say 3 times 4 makes 12. What I do the bottom must do the top. So 1 times 4 is 4. I times 4 by 3 to make 12, so times the top by 3. 1 times 3 is 3. So now what I've made, once again, using that word equivalent, I've used two equivalent fractions now. So 1/3 is the same as 4/12. 1/4 is the same as 3/12. Now we have a common denominator. 4 plus 3 is 7. We can now have an answer of 7/12. Getting the picture, hopefully? So let's have a look now. We're going to look at a couple of examples. I might use some subtractions as well. So we're going to do, let's have 7/10 subtract, let's say 1/5. Okay, so number one, can you find a common denominator? Well, hopefully you recognize they both go into 10. Okay, they both go into 10. So this is already in tenths. So I don't have to do anything to it. Like you can say times it by 1 and times it by 1. There's no point because we already have 7/10. But what can I make times it 5 by? Well, 5 times 2 is 10. 1 times 2 is 2. Now we either add or subtract the tops. 7 take away 2 is 5 over 10, which is also equal to 1/2. And if you can always simplify, I think that's a really good habit to get into. Okay, here's a couple to get you going. I want you to pause these and then see what you can come up with. Okay, so I want you to pause it, come back to it, and see, hopefully, you get the right answer. Okay, welcome back. All right, so for this question, I'm going to times the bottom by 2 and the top by 2 just on the first fraction. Why did I do that? Because I can now put them both over 8. So 4 times 2 is 8. 3 times 2 is 6. This is already in eighths. So I add them together to make 7/8. Hopefully you got that one right. Next one, I'm going to also put it over eighths. Okay, so times the bottom one by 4, top one by 4. So 1 times 4 is 4. The second one was already in eighths, so 4 plus 3, look at that, 7/8 again. Okay, what about the last one? Did you get this one right? Well, 2 doesn't go into 7 this time, so what I'm actually going to do is find a common denominator. Now, the real good little hint is, if you can't find a common denominator, guess what? Just times them together. That will always create a common denominator for you. It might not be the best one, you might have to simplify afterwards, but that's okay, we can deal with that. Okay, so 2 times 7 is 14, 1 times 7 is 7. 7 times 2 is 14, 1 times 2 is 2. 7 plus 2 is 9 over 14. Now, just before we move on, let's just double check. Can I simplify that down to anything smaller? 1, 3, and 9 go into 9. None of those go into 14. So bang, that's our answer. Okay, let's have a crack. Okay, I'm going to throw 3 more questions at you. 6 and 7, I've put an asterisk on them because they involve converting your numbers, well, if you want to do it that way, to improper fractions first, but then we'll look at how to do it as a mixed number as well. So pause it, let's see how you do. Okay, welcome back. Now let's have a look. The first one here, hopefully you can do that one now. So, well, 3 goes into 9, doesn't it? I was going to say we could make it into 27, but that's going to be easier. But times the bottom and top by 3. So we can get 8 ninths, subtract, well, 2 times 3 is 6 ninths, and that will equal 2 ninths. Now, if you didn't choose 9, and if you just times them together, this is what would have happened. You would have had over 27 minus over 27. So 9 threes are 27, 8 threes are 24. Then you would have had 3 times 9 is 27, 2 nines are 18. If I subtract those now, remember it's going to be over 27 this time. 24 take away 18 is 6. Now, I can simplify that further. You'll notice at the moment they are different. However, if we look at this and say, well, I can divide them both by 3 now. Both by 3. So 6 divided by 3 is 2. 27 divided by 3 is 9. And look at that. The answer is the same. However, you can see the first way was so much easier. So if you can see if the smaller number goes into the bigger one, then just do that first. All else fails, though, of course, you can times them together. Okay, now, the last two questions here was a bit mean, so my apologies. We haven't done huge amounts on improper fractions, so mixed numerals, addition and subtraction, so I thought I'd throw these ones in. Now, there are two distinct ways to answer these two questions here. The first of all, we can look at the lesson that we've done so far on converting mixed numbers to improper fractions, and that will always work. Now, when you're adding or subtracting, or when you're adding, should I say, you might get away with doing this. 1 plus a half plus 3 plus a third, where 1 plus 3 is 4. And now you can convert the half and the third to one fraction on its own. So what's a half plus a third? Well, common denominator of 6. 2 times 3 is 6. 1 times 3 is 3. 3 times 2 is 6. 1 times 2 is 2. That will equal 5/6. So we can chuck that there. So it equals 4 and 5 over 6. Okay, so that is one way you can do it. And often when you're adding numbers, that's actually the easiest way to do it. Okay, adding 1 plus 3. However, look, I'll be honest with you, in my classroom, I'll ask you to convert them to improper fractions to start with. Okay, what is that going to look like? Okay, well, 1 1/2. Okay, 1 1/2 will be the same as 3 on 2. 3 1/3 is the same as 9 on 3. So now what I've got is 3 over 2 plus 9 over 3. Now I can put them both over 6, like we we're doing before. 2 times 3 is 6. 3 times 3 is 9. 3 times 2 is 6. 9 times 2 is 18. We then come up with 27 over 6, which, lo and behold, is the same as 4 and 5/6. So you can see both ways work. Now, I said to you before that in my classroom that I will always ask people to do it this way first. You wonder why. That way looks a little bit longer, perhaps, maybe. But the issue is when you get a question like number 7, that really should be 2 asterisks. Because if I do 3 take away 1, well, that's nice and easy, that's 2. But how do I do a quarter minus 2/3? Because a quarter is less than 2/3. That's where I have a problem. So I always like to convert to improper fractions to start with. So I can create this to make it 3 times 4 is 12 plus 1 is 13 over 4. Subtract. 1 times 3 is 3 plus 2 is 5/3. I can now look for a common denominator. 12, that looks pretty good to me. So put it over 12 and put that over 12. So 4 times 3 is 12. 13 times 3 is 39. 3 times 4 is 12. And 5 times 4 is 20. I can now subtract them nice and easy. 39 subtract 20 is just 19 over 12. Or you could write 1 and it would be 7/12. Okay, now I apologise, those last two questions are a little bit tough, but please have a crack at those questions though. Have a look at my other lesson on converting mixed numerals to improper fractions and vice versa to help you out. But that's a quick introduction on adding, subtracting fractions. Have a great day.